Yeah, hello my students. Just as promised, I want to give you the final class for today. It has been a very busy day. But all the same, I promised giving you this, so I intend to keep my promise. Now the next thing we are doing the determination of utility, maximizing. I want to do this as much as possible. Maximizing combination of commodities subject to an income constraint. So you have seen that. So started by saying let P1, P2, P and B the price of the respective commodities X1, S2, Sn, and the consumer's money income subject to constraint of his fixed somehow. So I said the consumer, maybe I should look at it from here. I'm trying to see how you'll be able to get everything I'll put you through. Okay. Take my wife herself by bringing the light closer to me. All right. Thank you, my lovely wife. Now the consumer wishes to maximize his total utility function subject to constraint of his fixed income. Now his budget constraint equation is given as P1 S1 plus P2 S2 plus P3 S3 plus plus Pn Sn equals to I. The I just stands for his income. Now the P1 X1, P2 S2, P3 S3 all stand for the specific amount that is spent on each commodity. The price of the commodity multiplied by the commodity itself. For example, you have this P1 X1. This complete is what is spent on commodity S1, and it's what is spent on commodity S2, P2, S2, P3, S3 is what is spent on commodity S3, like that, and the whole income is consumed. There is no savings here. Now, to find the utility maximizing combination of commodities, as for the whole commodities, subject to the constraint of income, we introduce a new function Z, which combines the total utility function to be maximized with the budget constraint equation. Okay, so if you look at this, the function is called the Lagrangian function. We've talked about this, like I said in earlier video, that we are doing the revision of what we have done before, and this is named after a French mathematician, Joseph Louis Lagrange, who lived between 1736 and 1813. He was born in 1736 and he died in 1813. Now the Lagrangian function is generally given as, this is a general way of representing it, Z equals f of x1, s2, s3, to equal to Sn plus this this called lambda is a constant. We'll talk more about it as we go on. I'll give you an explanation of what it stands for. Now, you take the income, subtract each amount that is spent, the amount that is spent on each product that I tell you earlier on, So subtract from the income. This what is spent on commodity X1, what is spent on commodity S2, that is P2 plus P2 times S2 minus like that until you get to the last commodity, what is spent on the last commodity. If you do that, this is actually going to be 0. And by the time you say your income minus what is spent on each commodity, and you have 0, and you multiply that by the constant, which is lambda, you're actually going to get 0 and the whole function will be as the initial one. But for the purpose of pedagogy, that is for the purpose of teaching and information, we have to bring in this for easier analysis, and you understand this as time goes on. Because without that, there are some things that you get from without this. There are some parts of the equations that you get later on that you get from this that you will not get if this is not here. But the bottom line of the whole thing is that this function is the same thing without this. So for the purpose of explanation, we had to introduce this to make the explanation of what we are deriving easier. Now, where lambda is called the Lagrangian multiplier and is assumed to be constant. It's assumed to be constant. The next thing we'll do is that we proceed by finding the partial derivatives of z with respect to each commodity, and then equate, what we'll do next is to equate them to 0 to establish the first order derivative condition, the first order condition, that is first order derivative, that is first order condition FOC for constrained utility maximization. That's what we'll do next. So the next thing is to take that. So you take, by the time you take dz, the partial derivative of this dz dx, you have this. Later on I'll show you that this is the marginal utility of commodity x minus the lambda, that is the constant, the Lagrangian multiplier, the constant, times the p, because by the time you look here, when you differentiate this with total utility, all the others here, you differentiate this is total utility, like I said earlier on. Now all the others here will be 0. With the derivative of this one with respect to x1 will be 0. This one, there's no x1, it will be 0. If that will be 0 except this one. So if you differentiate this with respect to x1, what remains is minus p1. And when you have minus p1 here, you use it to multiply the Lagrangian multiplier. That's what you have, equated to 0. It's ditto for the same things here. The same thing goes for, by the time you take derivative of this with respect to x1, you have the marginal utility of commodity, commodity x1, which is dtu dx1 minus what you have here, lambda p2. Every other thing, like I said here, this will be 0, 0, 0. What you have left here will be what? Minus p2, multiply it by the Lagrangian multiplier. You have this, or have equated to 0. So it's something that goes on here until you get to the nth commodity. You have the same thing here. So the final thing you do is to differentiate the function with respect to lambda. And when you do that, the whole of this will be 0. All this here will be 0. And by the time you differentiate with respect to lambda will disappear, because lambda is same as lambda raised to power 1. So by the time you differentiate with respect to lambda, what will remain here, what will remain is this, which is what we have right here. I hope you can see that. So what we have here, we have them as equation 3. First is equation 3. Earlier one that we did, earlier one that I dropped here with you from the equation, you have the the budget constraint we named it as equation 1. I think, yes, I will name it as equation. This is a budget constraint. No, it's equation 1. Then we have all these other ones. Here we have equation. Okay, we have equation 2 as the Lagrangian function. So that is where we have this equation 2. Then we have equation 3, 4, 5, 6. Then the last one is, so we got to equation n. Okay, so this should have been equation n. Let's just leave it at that. But the essence is for you to understand what we're talking about, that you have to name the equations until you go to the one that we have to differentiate with respect to lambda. Now, the next thing that is expected of us is for us that we will solve equations 3 to n simultaneously to determine the consumption levels of the commodities that will maximize the total utility function. Now, to note that, like I said earlier on, that the TU, the X1 is the marginal utility of commodity X1, the TU, the X2 is the marginal utility of commodity S2, the TU, the S3 is marginal utility of commodity S3, until you get to the final one, the TU, the XN is marginal utility of commodity XN. Now, that of